Hello and welcome to Stocks Down Under. My name is Stuart Roberts and I'm one of the founders of our publication. And with me today is probably the brainiest man we've ever had on this show. Dr. Lee Finniear is joining us from Queensland Gold Coast. He's the CEO of LIS Energy, ASX LIS, 20th of October 2021. Lee, good afternoon.
Good afternoon, Stuart. How are you?
Well, I'm feeling pretty excited about life because as I like to tell people, my next car is going to be a Tesla. But I want a lithium-sulphur battery under the bonnet because I have a bit of range anxiety about my Tesla, and you have the solution for that in terms of your battery technology, right?
That's actually true. You know, range anxiety is a big inhibitor to people taking on electric cars simply because they don't want to run out of power halfway down to Melbourne from Sydney, for example. But the thing about a lithium-sulphur battery is it's got a much higher energy density, so we can extend the range of electric vehicles, aviation, drones, a tremendous amount using lithium-sulphur batteries.
Right, and not just a little bit. We're talking 5 or 6 times the energy density of the conventional lithium-ion batteries of the current generation, right?
That's actually true. The challenge with lithium-ion batteries as they stand is they have a maximum theoretical energy density of 380 watt-hours per kilogram, which they're almost hitting now. So there's not much room to improve anymore. Lithium-sulphur batteries have a theoretical maximum energy density of over 2,500 watt-hours per kilogram. So there's a much higher ceiling which we can develop those batteries into, which means we can produce batteries with a much higher energy density. That means a much longer range for EVs, a much longer flight time for drones or aviation. And this really lightweight battery. So we're really, really excited about it.
Right. Now, people have been working on the lithium-sulphur battery for a long time on the understanding that if you mix lithium into the anode of the battery, sulfur into the anode of the battery, you'll get that energy density. What you end up with is these outgrowths called dendrites on the battery, which basically means that its ability to recharge is severely reduced. But you've got some interesting chemistry to solve that, complements some geniuses at Deakin University. Share with us what the folks at Deakin have achieved.
Well, Deakin have done some amazing things. I don't know if I've got long enough to tell you about it all, but they started off by working both on lithium-sulphur batteries, but also on a unique nanomaterial called boron nitride nanotubes, or BNNTs. We've been able to use those BNNTs to stabilize the sulfur cathode in the lithium-sulfur battery.
Sorry, cathode. I think I said anode. Yeah, it's the cathode is with sulfur.
You were right where the dendrites form. They form on the anode, which is a pure lithium metal. And what we've done is also develop a composite nanomaterial working with Deakin to stop the dendrite formation on the anode as well. And those two things have been really important to be able to create that long cycle life for a lithium-sulfur battery. So you were right, Stu.
Right. And what's remarkable is people have been trying to produce boron nitride nanotubes for a long time. You know, things work in the nanoscale like they don't work in any other scale. But before Deakin, no one had been able to produce these things in a cost-effective manner. How did they achieve that?
Well, they worked hard for about 10 years, I must say, to start with. The challenge with boron nitride nanotubes, I'll call them BNNTs, that's what we usually call them, is at the moment, if you go out onto the market for a decent purity BNNTs, they cost about $1 million a kilogram. So crazily expensive. And what Deakin, working with BNNT Technology Limited as part of PPK Group, have been able to do is create a process which allows, instead of grams per week to be produced, to produce reliable, high purity BNNTs in kilograms per week, not just in grams per week, at a much lower cost. So we've been able to harness that material that was formerly very expensive and incorporate into our batteries, not only to solve the technical problem, but also at a commercially viable point as well. So we can produce a cost-effective lithium-sulphur battery with this kind of protection in it.
Right. Now, what's the next stage of the journey in terms of you have at least at bench scale a lithium-sulphur battery which has potential. We live in interesting times, so these things have a habit of moving ahead quickly. But what are the steps that you need to go through before we can really get excited about that?
All right. Well, we're already really excited about it, so you're quite welcome to get excited about it straight away. But what we've got is a single layer pouch cell that we use, or pouch cells that we've used for testing so far, and that's normal in battery manufacturing. You go from coin cells to pouch cells, and then the next step for us is to build what we call multi-layer pouch cells, which are like a double-decker sandwich rather than a single-layer sandwich, which allows us to increase the total energy density and the power of each of the cells. And then we're testing those at the higher energy draws, at higher charge and discharge cycles to ensure that they work in multi-cell layers as well. Having done that at a lab scale, we're then in the process also of building a pilot line to be able to automate the process of building those cells, so we can build larger cells at higher volume, so that people with devices, whether they're drones, electric vehicles, or other devices, can then take our cells and use them for testing.
Sure. Now, traditionally in the battery industry, there's various ways that you can pursue commercialization. Some companies I know talk to the battery makers in particular. Others go all the way up to the Elon Musk level, should we say? So there's any number of ways that you can pursue this. What's the ideal commercialization pathway now that these cells are taking shape?
The scaling of the battery industry in general is going through a huge revolution now. The volume of batteries required in 10 years' time is 10 times what it is now, thanks to the decarbonisation process that's going on, particularly on EVs. So our approach is, rather than trying, from scratch, compete with battery manufacturers, we'd rather partner with those battery manufacturers. Our commercialization journey involves getting the technology to a point where battery manufacturers will take it on to manufacture it. So we charge royalties for our intellectual property, but also then we have an exclusive distribution agreement for BNNTs, which are essential to build the lithium-sulphur batteries. So we'll get a slice both ways, if you like, both from the royalties, but also from the ongoing material usage as these batteries are manufactured and go global.
All right. Now, for investors who don't know you very well, that accent, I think you were saying before, comes from the West Country of England. You're a native of Bristol originally. You're not actually you didn't actually grow up in the battery industry or in the various technologies associated with LIS. Your background is a lot of time in the artificial intelligence game, right?
That's right. My PhD is in artificial intelligence and geographic information systems. So I started off, actually, I also have a degree in civil engineering. So I started off moving, building bridges, laying pipelines, that kind of thing. But moving on from that, then worked on the software side, developed a range of software and hardware solutions for things like location-based services, real-time tracking, and that kind of thing. But then I've also run a range of different companies involving electronics engineers, scientists, manufacturing engineers, and brought those to fruition as well. So it's a generalist kind of background, but in the technology space. And what I do know is enough to know when somebody is good at their job and they're able to do the work we need to do, and when they don't. And so my job is to bring the team together to deliver this commercial outcome as quickly as possible.
Right. And as I like to joke, there was a time when Elon Musk was pretty good at geospatial type mapping as well in one of his previous startups. So we all bring a certain amount of generalist expertise to the development of the 21st century economy.
Absolutely right. And if you're too narrow, I mean, you just don't see the broader opportunities in the space. And a part of the job is to make sure we get the right collaborations and the right partners in place to deliver this solution as quickly as possible.
Lee Finniear, thank you for joining us. Well done on the LIS Energy Float, and here's to a great couple of years ahead as you build out these wonderful technologies.
Thank you so much. Appreciate being on the show, Stuart. Thanks.